Hypersonic vehicles are gradually becoming a reality in our times, and this opens the door to using this technology, whether it's from passenger transport to intercontinental missiles. Welcome to this channel, I'm Sergio Hidalgo, an aerospace engineer. And today, the first Monday of September 7th of 2020, we start the hypersonic end of the year. 4 videos are coming that will be uploaded every first Monday of the month, in which we will talk about the main challenges that are posed today for hypersonic flight. And later I will tell you what are the solutions that are proposed today for those challenges. Because hypersonic flight is not yet consolidated today, and it is because of these 3 challenges that are posed. Without a doubt, this video series will be the most comprehensive on YouTube in Spanish. About hypersonic flight, subscribe if you're not subscribed yet so you don't miss them. And let's go with it. Before we start, it's very important to define what hypersonic flight is. What do we mean by hypersonic flight? Well, for that, of course, we have to use the Mach number, which, as you already know, I love to talk in terms of the Mach number, which is a dimensionless number that simply represents the speed at which an object moves. In terms of the speed of sound, so that a plane flying at Mach 0.8 flies slower than the speed of sound. A plane flying at Mach 1 flies exactly at the speed of sound, and a plane flying at Mach 3 flies 3 times faster than the speed of sound. And to give you a bit of context, the commercial flights on which transatlantic trips are made fly below the sound barrier, below the speed of sound. They usually fly at about Mach 0.8. On the contrary, today's fighter jets can fly up to Mach 2, even a little more, twice the speed of sound. Flight up to Mach 1 is called subsonic, and above Mach 1 is known as supersonic. But then, here comes the key question. When do you go from being supersonic to hypersonic? Well, the truth is that there is no Mach number from which the physics radically change from supersonic to hypersonic. As it happens from Mach 0.9 to Mach 1, there is a radical change in physics, but this does not happen from supersonic flight to hypersonic flight. And that's why it has been agreed upon by a convention. All scientists have agreed to call it hypersonic from Mach 5, but that doesn't mean that Mach 4.9 is supersonic and Mach 5 is hypersonic. As I tell you, it's more or less because hypersonic is started to be called when the temperature effects are extreme. Now we're gonna see what that means. But that doesn't happen at Mach 4.9 or at Mach 5.1. That starts to happen gradually, but by convention, as I tell you, has it been agreed that Mach 5 is when it starts to be called hypersonic. There is disagreement on what speed qualifies as hypersonic, with some saying it starts at Mach 3 and others saying it begins at Mach 7. The first artificial object that flew hypersonic was the German V-2 rocket, which exceeded Mach 4. In the 1960s, the X-15 reached Mach 6.7. The aircraft, which we will discuss further, was rocket-powered. This is, for now, the speed record for a manned aircraft achieved by Pitt Knight. But faster than that was the X-43, an unmanned experimental aircraft, which we will of course talk more about later in this video series, that nearly reached Mach 10. But the hypersonic regime practically has no limit, and far above all these aircraft are the orbital re-entries, with Mach numbers exceeding 20. Now that we understand when an aircraft is considered to be flying hypersonic, let's understand the 3 main problems that are presented today. In this video, it's simply going to be a presentation of these 3 problems, and in each remaining video, we will specifically talk about each of them. The first of all, and the most limiting from my point of view, is the issue of extreme temperatures. When an aircraft moves so fast due to friction or the shock wave it is generating, it is actually due to a combination of these 2. The air temperature rises to extreme levels, and the aircraft's surface in contact with the air does too. To this day, no material can continuously withstand these temperatures over time. In other words, maybe an aircraft can be put at Mach 5 for 5 minutes, but it couldn't do it for hours. It's completely impossible today with the materials we have right now, and this is because, through a shock wave, the temperature. Remember the shock wave video series I made? I'll leave a link in the corner. The temperature rises through a shock wave. But the most important thing is that within the equation, the Mach number is squared. When discussing hypersonic vehicles, the Mach number is extremely high. Therefore, the Mach number squared makes the temperature go crazy. All of this was more or less told by the SR-71 pilots. The book Scamworks tells a crazy, brutal story that I've already discussed on the channel. Basically, they talk about the design of the SR-71, the U-2, and the F-117. The thing is that the SR-71 pilots tell you that sometimes they had problems because of the temperatures at which the surface of the aircraft was. From outside, there are times when as the temperature got inside and they felt it, well, a real madness. This book is a wonder. I highly recommend it if you haven't read it. The second issue is what propulsion to use with a hypersonic aircraft. It's very likely that many people think that hypersonic aircraft will be rocket propelled. Rockets are not ideal as they require carrying everything inside the aircraft, resulting in increased weight and other issues. That's why they are used in space, because you don't need to have air around. An airplane engine, for example, takes air from the atmosphere, puts it into the engine, compresses it, explodes it, etc. But rockets can be used in space because they don't need that air. You carry it inside with the spacecraft. But for hypersonic vehicles, which are intended to be used profitably, it's not the best idea. Conventional airplane engines that are used today are also not a good idea. When you go that fast, it's completely impossible to use those engines. There's no possibility of using them. But two types of propulsion appear quite plausible for hypersonic flight, which are the ramjet and the scramjet. But these present other problems, as to start working, you need to go at least up to Mach 4, but how does the aircraft get up to Mach 4? Well, all these questions too, of course, we would say. What is the best engine a hypersonic vehicle can use? We will answer all these questions about the engine in the November video. And finally, we have the topic of design. What shape does a hypersonic aircraft have? Because, for example, the X-43, as you can see, has this shape, which is quite strange from our point of view. But a hypersonic aircraft was also, for example, the X-15, which has a completely different shape, or even the Space Shuttle, which is completely different. These three are completely different designs from each other. In the December video, I will tie everything together to help you fully understand the hypersonic vehicles of the future. Of course, these three problems are not the only ones. There are many more problems, but these are the main ones, until those three are solved. There's no need to think about the rest, but I'll share some other important things. For example, the aircraft absolutely has to be fly-by-wire. This ensures the aircraft constantly monitors its speed, external temperature, density, and other parameters through onboard instruments. So that the pilot, if he wanted to turn left, would move his hand to the left. He would be telling the plane's computer how he wants the aircraft to move. And once the aircraft interprets what the pilot wants, it moves all the control surfaces so that the aircraft moves in that way. Unlike ultralight aircraft, which operate via a system of cables and pulleys controlled by the pilot. And the ailerons always move in the same way. No. When using fly-by-wire, especially when we're talking about supersonic or hypersonic vehicles, the pilot tells the aircraft what he wants to do. The aircraft adjusts its control surfaces as needed to respond to the pilot's commands. It's absolutely mandatory to use this fly-by-wire system because the aircraft, when going so fast, a wrong move of a control surface that deflects more than necessary would cause the aircraft to completely break apart, disintegrate on the spot. Another problem would be that we probably couldn't study all these phenomena in a wind tunnel because it's very complicated to imitate in a wind tunnel. Conditions of more than Mach 10. Keep in mind, when we talk about Mach 10, we're talking about 10 times faster than the speed of sound. Therefore, wind tunnel analyses are quite impractical and we need to use computational fluid dynamics, which are basically computer analyses. The problem is that removing the wind tunnel eliminates a necessary tool. Other problems also arise from here. And also, if these aircraft want to be used as missiles, it's extremely important. It's very important, really, a lot, that they are very precise, but a lot. Because if a hypersonic missile at more than Mach 15, for example, were to hit a building, it wouldn't even need to carry explosives. With all the energy that the aircraft carries by flying at Mach 15, an incredible amount of energy would be released. And that's why if you're gonna use them as missiles, you have to be 100% sure that you're gonna hit the target. If not, it can cause massive destruction. Another very important thing that I haven't mentioned yet is that these aircraft usually fly very high, much higher than commercial planes, where the density is very low. In fact, they are considered even suborbital flights because they are practically leaving the Earth's atmosphere. Well, Yankee of science. I hope you liked this video about the main challenges posed today for hypersonic flights. Let's hope they are solved in about 20 years, so that around 2050 we can be flying in hypersonic vehicles. If you don't want to miss the next videos, subscribe to this channel below. If you want to contact me, you can do it through Instagram or LinkedIn. You know, I'm always there. By the way, I've started a podcast. I'll leave the link below so you can listen to it. A podcast about aviation. I think all of you who are watching this video are going to love it. If you've made it this far, you're going to love that podcast. Subscribe to this channel, and then you can watch one of the best videos on the channel. You know, always, above all, science lead. And let the hypersonic end of the year begin.